There we go. And over to you, David. Thank you very much.
Many thanks, Susan, and thanks for organising the session. So the reason we've called it What a Puzzle is that the usual explanation for why curves are unstable are that they exclude variables that shift, or they have other variables that are included that are distorted by variables that shift, so have the wrong coefficients and therefore appear to shift. And that is not at all what is going on here, which is quite a puzzle relative to what I had previously understood about econometrics. So here's a route map for the talk. Many of you might not know much about Bill Phillips, so I'll do a little introduction on him, then discuss the original Phillips curve. All our work concerns the original Phillips curve, not the many variants that have happened since, and then look at its instability over time. And then Jenny and I have several times published on a real wage model for the UK that has been constant since 1860 right through to the present. And that can be converted to a nominal relation, and we'll derive that nominal relation and do a misspecification encompassing analysis. Can it explain why the Phillips curves are shifting? And the answer is yes, it can. So you can get a constant model to explain a non-constant model. Then we'll look at subperiod implications, exactly the subperiods that the Phillips curve's known to have shifted in, and show that there's really interesting implications that, again, add to the puzzle as to what's going on. Then we'll test the validity of conditioning in the variables and show that, yes, we can do that. And then finally address what caused the shifts in the subsample equations and draw some conclusions. So Bill Phillips is otherwise really known as Albin William Hosego Phillips. And he was born on a rural New Zealand farm just after World War I started, within 3 weeks of the start. And his father had constructed a hydroelectric scheme on the farm using a local river. And so Bill was able to read books at night in a way that most people in rural New Zealand couldn't do for about 20 years afterwards. That meant he was way ahead of what was happening in the local school. And so he left school early to work in Australia as an engineer, and did so for quite a while, 5 or 6 years. He got fed up and bored, and so decided to explore the world. And in 1937, he went to China on a Japanese ship landing in Tokyo. Took a bit of time to get disentangled from Japan to get to China. But when he got to China, it was just as Japan invaded China, so he had to flee to Russia. He then crossed Russia on the Trans-Siberian Express to get to Germany in 1938 and on to the UK, where he joined the RAF as World War II broke out. He got a tremendous reputation as an engineer repairing Spitfires, and so was sent to Singapore to try and help it maintain its tiny little Spitfire Air Force, and was one of the last people to leave Singapore before it surrendered. And the ship he was on was regularly attacked by Japanese aircraft, and there figures in several biographies by other people as being the one person standing on deck holding a submachine gun and firing at them and hitting several. Anyway, the ship got to Java just as the Japanese invaded Java, and he got caught there and spent 3.5 years in a prisoner of war camp, where he had some extraordinary exploits that are also mentioned in other biographies. One was making a little steam oven underground that could make hot things for people who were ill. And he also made a tiny radio hidden in a clog heel, where he got the parts by going into the commandant's office, taking the bits out of his radio, putting in wooden bits that looked like the bits that had been there, and built this radio. So when Hiroshima and Nagasaki were bombed, he warned all the troops in the prisoner of war camps that they might be executed by incandescent Japanese guards, but in fact the Japanese guards surrendered. War left him devastated and a chain smoker, but he was funded by the government, with as many troops were, to do a sociology degree at LSE. He failed this because he simply couldn't last the 3 hours in the exam and had to go out to smoke. And in those days, if you went out of an exam, you could not get back in again. So he was left degreeless. He happened to be sharing an apartment with a Keynesian economist, Hawtrey, and that led him to want to build a machine to look like an economy. So he tried to convert swords into plowshares quite explicitly in 1949 by getting material from scrapped warplanes to construct his hydraulic machine, MONIAC, the Monetary National Income Analog Computer. And here's a picture of MONIAC, which is still working in the Reserve Bank of New Zealand and in the London Science Museum. And it's purely hydraulic. It just uses water in coloured forms circulating to show how the economy functions. LSE asked for a demonstration of MONIAC, and it impressed Lionel Robbins, who was a very right-wing fundamentalist economist who thought that economic theory was the only thing worth doing and anything else was a waste of time. But he was very impressed by MONIAC and appointed Bill to an assistant lectureship in 1950. Note, he had no degree. But by 1958, he was promoted to be the Tooke Professor of Economics, the most senior chair in the department, in the most rapid promotion that's ever happened to the Tooke chair. Bill is, of course, now mainly remembered for the Phillips curve, which links nominal wage inflation. We're going to use the change in the log of nominal wages, lowercase letters to note logs, and connected that to the unemployment rate, because he felt that as unemployment got very low, workers could bargain for higher wages, and when it got very high, firms could beat workers down and pay them lower wages. I very gratefully remember Bill, as he was my tutor at LSE in 1966-67 while I was doing the MSc in econometrics. That was the last year he was at the school. And he very successfully guided me through my initial struggles with econometrics, which Graham Misen and I recount in our book, in our article about Bill. I didn't know his war experience at the time, but to give you an idea of how far behind I was when I started the MSc, the very first lecture was by Jim Durbin. And as we walked out, I turned to the person next to me and said, "What's a likelihood?" And he turned around and said, "By God, you're in trouble." Anyway, we became good friends and he helped me. Bill and Dennis Sargin ran an inspiring workshop for MSc students. It was the only year this happened, where they debated issues including exogeneity, which is very useful for me later. Bill was moving average errors, Dennis was autoregressive errors, Bill was continuous time models, Dennis was discrete time models, and Bill was nominal wage determination, and Dennis was real wage determination. So there are lots of very interesting debates, of which we'll come back to that at the end. Pravin Trivedi worked with Bill on estimating moving average errors, while I researched autoregressive errors with Dennis. And in 1969-70, Pravin and I did a comparative Monte Carlo study of them, and we compared how well each approximated the others, that is, moving average by autoregression by moving average, and each by their own, and found it was pretty good if the leg orders matched. We then decided to try forecasting, and we examined respective forecasts using antithetic variates, something I mentioned to Jeremy last week in his talk. So you got the error vector that you fed into the simulation, ran it and see what the forecasts are. Then you replace that error vector with every term being the negative of the previous one, ran it again and averaged. We printed out every forecast error to see what the outcomes varied across all four cases, which of course were mainly misspecified. And we got 300 pages of zero. And we had to answer to a furious head of the computer unit. Now, clearly, we did not expect that, but fortunately, we were able to explain that astonishing result, how computationally burdensome, generalized least squares, nonlinear parameter estimates of misspecified models with autocorrelated errors could possibly produce unbiased forecasts in all states of nature. And there's a little bit of algebra down here that meant we had proved a theorem that was extraordinarily difficult for people to do, namely generalized least squares involves estimating an error process, moving average or autoregression, and this is the whole matrix of the error process, and it's x prime x, and then that's reinverted, and then it's multiplied by that times the inverse times y, and yet this, which you couldn't work out the expectation analytically, is an unbiased estimate of the true parameter, because all these are positive terms, and when you change the error, you simply shift the y up and down, and it cancels when you average. So I had discovered that forecasting is very different from estimation. So what's the original Phillips curve? Well, he related changes in nominal wages, capital WT, to the unemployment rate, UR, as both are labour market variables. And being a continuous time band, he took a discrete approximation, which is half WT plus 1 minus WT minus 1 over WT, which is his measure of wage inflation. We're just going to use delta WT, as I mentioned. There's differences in timing of peaks and troughs, but they're very highly correlated, as I showed 20-some years ago. Other variants of the Phillips curve use price inflation, and Kevin Hoover provides a historical perspective in that, but the real Phillips curve is on wages. So figure 1 compares these. I'll go to figure 1 and come back. So this is mimicking the original Phillips curve. Delta W, this purple line where the dates are the data for delta W, shows the fit, and it is slightly nonlinear in the way that Phillips did. He had it going up much more, and I'll explain how he got that. Whereas the price, which are the red circles, are a straight line. So the original Phillips curve, which is fitted from 1860 to 1913, it's pretty much reproducible. And that's despite the fact that the unemployment data have been hugely changed. So this cubic spline is kind of attempt to match Phillips' nonlinear form, but price inflation, even by a cubic spline, looks like a straight line. Now, Bill at the time was making important theoretical contributions to estimating continuous time models, and was aware that discrete approximations of the kind he used created moving average errors, which is precisely why Pravin and I were working on them. But at the time, they're nearly impossible to estimate. He also knew that the loops around his long-run relation represented dynamic adjustments, so his equation was static. He didn't attempt to compute standard errors or anything around it. So in order to adjust for this, he calculated his equation from subsets of unemployment levels within which the average over a business cycle should be close to 0. And this is recounted by Begner Desai in his paper. And here are Phillips loops around his curve. Now, the best way to see these, I've only picked 1860 to 1880 because otherwise it's a mess. But if you start in 1880, you can see it goes down to 1879, 1878, 1877, 1876, 1875, 1874, 1872, 1, and then comes down into the 60s, drops down to 1869, and then back up. So you can see there are loops around it, which are the dynamic adjustments of which Phillips was aware. However, Bill only fitted it to the pre-First World War data. And I'm going to demonstrate instability, and again, come back to this slide and show you just how unstable they are. And the curves are, there's the one that Bill Phillips had. This blue one is the First World War through to the Second World War. So it's 1914 to 1945, which is one of the most turbulent periods in British economic history, but it's almost the same as he found for his rather quiet period from 1860 to 1913, which is a puzzle. How come, despite all the shifts, high levels of unemployment, US Great Depression, price indexation, First World War, Second World War, price controls, you get roughly the same equation? Then we get to 1946 to 1980, and it's completely different. It's sloping strongly upwards. And if we go to the more quiescent period, 81 to 2011, it's also sloping upwards. And over the recent years, it's absolutely flat. So they're all over the place in ways you wouldn't expect, and they're constant when you wouldn't expect them to be constant, and not constant when you might expect them to be constant. That's another part of this puzzle. So we get every possible slope in the relationship between change in nominal wages and unemployment rate, strongly negative, slightly negative, flat, slightly positive, strongly positive. And what we're going to do now is compare these outcomes over the same subsample by those that are predicted by Jenny and my econometric model of real wages, which has been updated to 2021 in a recent paper by us, but re-expressed in terms of nominal wages by taking the delta inside, so it's delta W minus delta P, and taking the delta P over the other side and seeing if our constant model of real wages can explain the variability in the Phillips curve. oops, what happened to that graph? Must come slightly rather later than I remember. So the sub-periods are Bill Phillips' original period, World War I to end of World War II, the post-war recovery till the end of the oil crises, the start of the Thatcher regime till the sample end that Jenny and I had in 2014, and then the period with Brexit, COVID-19, lockdown, and UK's furlough scheme. And notice it was completely flat over that. I showed you the outliers from wars, oil crises, price controls, indexation, US Great Depression, but they don't seem to explain what's going on. That the Phillips curve did not fail during the great turbulent period from World War I, the UK crash in the post-war period, the US Great Depression, World War II. It's really surprising, although the downward slope estimate did double. But sloping upwards during the two post-war periods and flat since does seem less excusable and suggests that this is not a stable relationship. So here are the estimates of regressing delta W on the unemployment rate in the subsamples, minus 0.67, which is pretty close to what Bill found, minus 1.3, which is the doubling that occurred, but still sloping downwards. Then suddenly a big positive coefficient, another positive coefficient, and then an insignificant negative coefficient. So this is what happens when you do our misspecification encompassing. So we take our model, we get its fitted values, and then we fit the subsample regressions that Bill Phillips did, regressing now with our predicted values of the data, regressing delta W and UR. And as you can see, they're almost exactly the same, right? All over. Now that's very surprising, because the natural explanation of unstable estimates is that relevant variables are not included in the model and experience shifts. But if all excluded variables were stationary and had a constant correlation with the unemployment rate, its coefficient would be constant despite any amount of omissions. Conversely, if the additional regressors in our model of real wage growth explained the shifts in the sub-period regressions, then they should match very closely, and I've shown they do. So the close match confirms that the additional variables in our model account for the instabilities in the Phillips curve. But why? Since our model is constant, how do you get a constant model to correctly encompass a misspecified model that's shifting all over the place? Well, here's our real wage model. And don't black out, I'll explain it bit by bit. The main thing is we're explaining the change in real wages by the change in productivity, that's output per person per year, acceleration in inflation, the unemployment rate squared, but both of these are deviations around the long run unemployment rate of 5%, the change in the unemployment rate. Then we've got a wage price spiral effect that I'll discuss. Then we've got some step shift indicators for 1939, 1940, 1941. There's a couple of outliers, one in 1916, one in 1977, and then outliers in the Second World War from price controls. This is the feedback. This is real wages relative to productivity. So that's wage share in the economy, again, adjusted for its mean, so we don't have a separate mean in the equation. And then we have a reversal of all the changes in 2016. So the coefficient standard errors are all pretty standard, but the model is constant over Brexit, the pandemic, and the furlough scheme, and passes tests for super exogeneity. And this is the fit of the model for real wages over time, and I've put in the bits that are done by the indicator variables. This is it fit, it's pretty standard. It forecasts better than it fits, which is amazing given that this has got so many turbulent events. But again, that's part of this puzzle. The residuals are approximately normal and not autocorrelated. So let's walk through the model term by term to see what's going on. So first of all, there's the change in productivity, and that adds up to about a half. And that's very quick. About half the change in productivity gets converted to the change in real wages within a year and a bit. Then we've got the feedback, the long run adjustment. This is kind of Sargon-like, in which if workers' share of national income falls, then that'll lead to an increase in the rate of inflation of real wages. And if it rises, the converse. So this is the long-run equilibrium correction feedback, and it's got a half-life of about 4 years. So again, pretty rapid adjustment of real wages to what's going on in the economy. Then we have a term for wage price spirals, and this is logistics smooth transition autoregression, squared annualized inflation. So this is annual inflation as a transition variable, and there's a threshold C and a speed of transition gamma, which we estimate, and these come out to be 0.2 and 10. And the points are calculated from the observed data and scaled by 0.88. So this varies between 0 and 1, given the units in the annualized inflation. So that creates this U-shaped curve. And there's little reaction of real wages to price inflation when price inflation is low. But as you can see, as price inflation rises, the reaction gets bigger and bigger and eventually ends up at 100%, which is 0 because this is a negative term. Now that happens once inflation gets above 6 to 8%, you start to get the wage price spiral in that wages go up because wages go up, prices go up, means wages go back up and so on. And this is rather unusual, but represents pretty well what's been happening in the British economy recently. But it also happens in the reverse direction. So immediately after World War I, wages were indexed to the price of coal. The price of coal collapsed when the war ended. Real wages collapsed and inflation went to -20, and all of that was passed on to workers, which is what leads to the dreadful turbulence and the general strike in the 1920s in the UK. Now, currently, inflation in the UK exceeds within the band 6 to 8% and was above 8% in May. So the wage price spiral is a key concern, and it isn't present in the Bank of England's model. So they may well have been seriously misestimating how persistent and how significant inflation would be by not having a wage price spiral kicking in once inflation got high enough. Now that term's very significant. Earlier in our work in 2014, we used a different measure. It's very highly correlated with the L-star. Actually, it yields rather better results, but econometricians being what they are, the referees always demand that you use a sophisticated thing rather than this dead simple way of approximating a wage price spiral. Then we have the unemployment terms. And this is a non-linear unemployment effect. Now, notice we're having important nonlinear terms. We've got breaks. We've got many variables. And so the nonlinear term means that initially, unemployment has a negative effect on real wages, which is what you'd expect. Workers are losing bargaining power. But eventually it turns positive. And what we see, if we plot it, is a graph like this. If we put the unemployment rate here and the solved unemployment impact on real wages, it starts off being positive when unemployment's very low. It falls steadily as workers lose bargaining power to about 8%. Then it starts to go right back up until it goes way above where it was. So when unemployment gets to about 18%, real wages are much higher than they were when unemployment was 0 or near 0. That tells you that unemployment is involuntary, because if workers are willing to work for this real wage when everyone's working, they would obviously much prefer to work for it here. And what's happened is there's a movement along the marginal productive labor curve, and it's raising real wages for those still employed, both because they've got more capital per worker, so fewer workers, and they're the more productive workers because firms are probably quite good at getting rid of the less productive workers. And this is badly misinterpreted in the Phillips curve literature. It's not that high wages are causing high unemployment. High unemployment is causing high real wages. Patrick Minford has never understood that that's possible because he doesn't believe that unemployment is involuntary. But you don't march from Jarrow to London as if it was a holiday if you could get a job. And then we have the step indicators. Now, the 1940 indicator is due to Maynard Keynes, and he tried to raise real wages very dramatically because price inflation was practically zero, so nominal wage inflation is more or less real wage inflation, to get women and retirees and older people into the labour force because everyone else is getting conscripted to fight the war. And this effect actually becomes permanent. The upward shift that happens hangs in until 2012. And then in 2012, it reverses. Now, we don't know why. We do know why this one jumps. That's Maynard Keynes getting the government to mandate increases in wages. But these two on the other side are due to war effects, hiring more people than when you get to very low levels of unemployment, it's possible that these aren't quite working. But in 2012, it reverses, and we don't know why it reverses, but this is a very, very significant effect. And of course, it's consistent with the stagnation of productivity since about 2012. Now, if we express our real wage equation as a nominal equation related to unemployment by putting the change in rate of inflation in this box. So this box are all the other variables other than unemployment. And if you solve out for what the unemployment coefficient is, lo and behold, it's almost exactly Bill Phillips' coefficient, minus 0.71. And then there's all this stuff. So to find out what's going on, we correct our measure of real wages, nominal wages, by all of these things that we call X. So we create the full sample residuals from regressing delta W on X. We call it X hat because we're using the estimated coefficients to add all these up to get the scalar. So it's the sum of all the influences in 3, other than UR, which is separated out. And then we look to see what's the relationship between delta W and X hat. Now, many of you, if you're econometricians, will immediately say, oh, you ought to use the Frichois theorem. You've got delta W on UR and X. You take it out of delta W, you should take it out of UR. Believe it or not, UR is orthogonal to X. So the rate of unemployment is completely uncorrelated with all the variables, including other measures of unemployment, that are determining the change in wages. Now the puzzle's getting really serious. What on earth is going on that this lot doesn't affect unemployment, but does affect the rate of inflation of nominal wages? And that's what's happening. If you regress delta W, you get almost a unit coefficient in delta X. It's only corrected by a full sample scalar. It uses the same coefficients in all subperiods. But if you now run the regression in subperiods of this full sample correction, what you get, minus 0.76, minus 0.72, minus 0.85, minus 0.67, minus 0.84. In other words, you get almost the same Phillips curve in every period once you've corrected for X, which has no effect on unemployment, right? And that is truly extraordinary. We now have no idea what's going on. How come you can get all the same coefficients correcting X? It doesn't affect unemployment, but you get the same coefficient for the regression on unemployment over the sample. And this is in sharp contrast to what we saw from just using unemployment, where you got it jumping all over the place up to +2 and down to minus 1.3. So something else is going on that's explaining all these movements. And this is what the corrected subsample Phillips curves look like. Absolutely fantastic. They go straight down, all of them, in almost exactly the same way over all the subperiods. So that's obviously whatever's going on is explaining why they've shifted, because this explains why they wouldn't have shifted had you used our model. So it does turn out that if you simply regress delta W and UR over the whole sample, you get basically Bill Phillips coefficient. Now that can't be a surprise, because we've already shown you that this is not affected by delta X. Only this is affected by delta X. So that without accounting for price inflation, labor productivity, the wage share, nonlinear wage price spirals, nonlinear employment effects, exogenous shocks, wars, oil crises, all the subperiod curves are non-constant, but not, if you account for all of these, they suddenly become constant. So these additional drivers obscure the same Phillips curve hiding underneath over the last 160 years. And that's what we show in this graph. This is if you use the corrected data, taking account of the X, but not changing the unemployment because it's not correlated. And this is what you get if you just regress wages and unemployment. It's fine in the full sample, but it's all over the place on the subsamples. Well, you've seen these are almost all exactly the same in the subsamples. Now, in order to see whether it's valid to do all of this, we need to show that U is super exogenous in the regression of our adjusted data on U. So to do that, we try to find out what are all the big shifts in U? Where did it change most unexpectedly? And these are the dates, 1920, 38, 74, 80, and 84. And they're very big changes and explains much of the variability of the unemployment rate. But if you add them into our model, when you've got X, they're highly significant. So it shows they are picking up most of the behavior of UR. But if you add them into the adjusted model in unemployment, they're completely insignificant. In other words, all the big shifts in unemployment are conveyed to the dependent variable through unemployment, and therefore it's super exogenous. And these are irrelevant variables in this equation. So now we know that it's valid to regress our corrected variable on the unemployment rate. It's super exogenous, and yet it's all over the place when you don't do this. What's going on? Right. What caused the subsample effects? And this was completely new to me. I've never seen this happen in an equation before. So we now look at our model in the subsamples. These are the full sample estimates you saw earlier. These are the subsample estimates in the first subsample, and you can see they're all significant. If they're not significant, that is, their t-values aren't bigger than 2, I've put them to 0 so you can see the patterns of what's happening. So the second period is rather similar to the first period, although there's a couple of zeros. But the third period is absolutely nothing like it. We have 1, 2, 3, 4, 5 of the key variables are insignificant in the third period, and 1, 2, 3, 4, 5 are insignificant in the fourth period. So what we have here, which I found extraordinary, is that it's the lack of significance of all these turbulent changing variables that stops the Phillips curve from being constant. It's not the shifts in them, it's a lack of shifts in them that's causing the problem. It's the absent impacts on unemployment in the wage equation that's explaining the upward slopes. Because these don't have any effect, the equation goes upwards. And it's almost the same here. These don't have any effect, so it goes upward at a less steep rate. And in the third period, most of them are too small to, they are significant, quote unquote, but the sample's pretty much unreliable. So suddenly we have the puzzle resolved. The puzzle isn't due to shifting variables causing the equation to crash. And that was obvious because the 1914 to 45 has never seen so many shifts. And yet it was almost exactly the same estimates as Bill Phillips' original period. Then we come to a quiescent period, post-war reconstruction. Only at the very end does the oil crisis begin to disturb it, and suddenly it sloped upwards. And that's because these effects aren't having, these variables aren't having any effect on the outcome. And similarly, in 81 to 2011, most of them are still insignificant. So it's the lack of variability. You need all of these varying in order to have a constant Phillips curve, which is ridiculous, but that's what is going on. And it was almost predictable from the fact that the unemployment rate was orthogonal to all the others. So the low levels of unemployment from 46 to 80 explain its insignificance. And now we do the final explanation of what's going on. If I replace the estimate, the zeros, by the full sample estimates of the X's, they're not significantly different from the unrestricted fit. Sigma tilde is 1.17 versus 1.11. And similarly for 81 to 2011, it actually fits somewhat better, forcing are full sample estimates versus the subsample unconstrained ones. So no misspecification tests are significant for these constrained models using the full sample estimates in all the subperiods. And what do we find? Well, we find that it's constant in all the periods. So if we use the full sample estimates in the subsamples, so we keep those coefficients, then that X variable explains the constancy right across. But if you estimate the model in the subsamples, and these are not significant because they're not varying, you get the Phillips curve shifting all over the place. Now let's look at the data, and we begin to see something of what's going on. This is Bill Phillips' period. This is the First World War, the Second World War. That's the interwar period. This is the post-war reconstruction and then the oil crisis. That's the next cutoff date. This is the Thatcher era right through to when Jenny and I first tried this model. And that's the period since with Brexit and pandemic lockdowns, etc. And for unemployment, this is the new data on unemployment. It looked rather different when Bill Phillips was using it because it was only unionized data. And there was great work being done by economic historians to show that the non-unionized data had very different patterns of unemployment. The shop girls and servants, etc., depending on the variability over time. And unemployment was on average higher than the unionized labor. But you can see this has got very little relation to what's going on up here, and yet you get a constant Phillips curve. Then we get the war, and the two wars enter and leave at roughly the same level. Wage inflation's near zero when we enter, wage inflation's near zero when we leave, unemployment's near zero when we enter, unemployment's near zero when we leave. But in between, it's completely different. This is the post-war crash, 20% drop in real wages. This is the unemployment effect, that this huge increase in unemployment from the US Great Depression doesn't show up at all in wages, which is, if you like, why it's amazing that the relationship is constant. And then we get the the recovery period. Now notice how low unemployment is. That's 5%, 4%, 3%, 2%, and that's 1%. So we're talking about 2% unemployment. Can you run an economy without inflation at 2%? You bet you can. We did it for about 20, 25 years. And it's only when the oil crisis came along that things started to go badly. And then, of course, we get much higher unemployment with Thatcherism, and it's not related to what's happening in wages. So again, it doesn't work. And then we get the final end period. So what are the conclusions? So the UK Phillips curve relating changes in the log of nominal wages to unemployment rate is definitely unstable. The sub-period relations of wage inflation to unemployment can be strongly negative, flat, slightly positive, and strongly positive in the time series divided up by reasonable sample periods, which don't, obviously, the first one is fixed by Bill and the other ones by, if you like, national events. So we show that a misspecification encompassing test revealed that the subsample shifts were matched by a fit of a constant parameter real wage model. By parceling out the full sample sum of regressors as a scalar, other than the impact of UR from delta W, all subsample equations had slopes over a very narrow range. And this doesn't need partial out from UR because it's orthogonal. And then we can test the validity of conditioning of delta W and UR by superexogenated tests, and they confirm that it's valid condition. Then what we find is the insignificance of subsample variables that are significant in the full sample real wage model due to little time series variation. And that is clearly what's explaining the shifts, because if we impose the full sample estimates on these insignificant subsample coefficients, we get no deterioration in fit, and we identify the culprits behind the instability was the absence of significance of these variables, not shifts in other variables. Now, of course, in some sense, this is an exercise in economic history. because although the whole sample regression of delta WR delivers the same coefficient as a more general constant parameter equation, it's not a useful way to model the inflation-unemployment relation important to economic policy. What we show is you can get a constant real wage equation, which allows for involuntary unemployment, which allows for wage price spirals, which allows for nonlinear reactions, which allows for feedbacks, for productivity, for shifts that can't be explained but are probably due to changes in measurement systems. All of that could be useful and explains the original Phillips curves, but you need to interact the real wage equation with a pricing equation, which is what Jenny, Andrew Martinez, and I did in our recently published 2023 paper. The Bill and Dennis debated nominal versus real wage models, as I said at the beginning. So we've come full circle. Dennis's real wage equation entails constant nominal wage equation when adjusted for the same regressors. Thank you. Happy to take questions. Lucas. About, well, no, these aren't questions. These are cheating on.
Thank you, David. If anyone has got any questions, do raise your hand or pop them in the chat. I see that some of the ones in the chat have been answered.
Perhaps David would like to answer the questions in the chat rather than me. Do you want me to read out some of the questions, David?
Cheat, yes.
How does the goodness of fit compare between periods?
It's very similar. I haven't got them all to hand, but they're all round about 1% for the standard error of the residuals in the various periods. It's a little bit bigger in the interwar period, but not much. And you saw, if I go back, in fact, you have it for two of the periods, 1.17, 1.11, they're all in that kind of region. And it's a bit better for the quiescent ones at 0.98, but they're all somewhere around about a 1% fit in all the subsamples.
And just to clarify, that's when conditioning on all of the exogenous regressors, because there's quite a bit of variation when just looking at the raw Phillips curve model.
Oh yes, they're all Phillips curves, got very different fits in the different subsamples.
Another question was about if wages are minimum wages, increasing minimum wages can or cannot impact unemployment. Will the model differ for minimum wages?
Don't think so. We obviously haven't separated out minimum wages. We've got the total wage bill of the economy. That's if you think about it, W is the wage bill in nominal terms, capital W. Little w is the log of that. Delta W is the change in the wage bill. And in fact, we have here what this would be the real wage bill, and this is the real output per person per year. And they're beautifully co-integrated. I haven't showed you a graph of that, but they track each other extremely closely. So whatever's happening to nominal wages has to be picked up through the changes in the level of productivity, the changes in productivity or the price. But it doesn't seem to show up in the aggregate data. But you might find something different if you look at very disaggregated data on minimum wages.
And then what about checking other countries?
Go for it. This has taken years to get all the data and do all this. There's no way I'm about to start checking other countries. But I doubt it will work for America because they don't seem to have wage price spirals and the kind of Phillips curves that they do. And also North Americans really believe that expectations matter in Phillips curves. And what we show here is they're completely irrelevant because we can explain everything without them. Although some of the combinations of variables in the X might well be approximating how people form expectations, but I doubt it.
There's one more question in the chat, and then both
just a sec.
Emma and John have
Just a sec.
Oh.
So how would anybody in 1914, having seen the last 40 years, 30, 50 years of data, suddenly expect it to go to 25%? There's simply no way anybody anticipated wage inflation on that scale. And no union would have agreed to indexation on the price of coal if they had any expectation that it would fall by 20%. And ditto, when the war broke out, nobody expected the government to mandate a 14% increase in nominal wages. I mean, these are not things you would possibly expect, and they're all the big events. Likewise, the oil crisis. Again, it suddenly became unexpected that Britain could have 20% inflation and had to go to the IMF to get bailed out. So I just think that expectations have nothing to do with it.
One last question in the chat, and then Ebba, and then John. So in the chat, do you have a narrative for why different terms drop out in each period?
Yeah, the lack of variability.
Ebba?
Yeah, thanks, David. My question was about your motivation for the choice of time subperiod. So was that motivated simply sort of historical choices, or? Yes,
totally. The historical choices were, clearly we had to take Bill Phillips period up to the First World War. Several people, including Dick Lipsey, had fitted his equation to the interwar period from 1914 to 1945, because in the 1950s, you're here, this is all the X new data you've got. And he found roughly the same equation, although he did add in other variables. So that seemed a natural thing to do. And then the period up to the end, the second oil crisis, you could have done the whole thing, but it wouldn't have made much difference over the whole period as they're both sloping upwards. But yes, so these are all known historical periods. And of course, the Thatcher revolution of privatizing everything, destroying the wealth of the nation, and spending all the oil resources and unemployment benefits, etc., fighting the miners and causing real strife and then dumping them. So this is a very different period. And this one is where Jenny and I stopped, because that's when we published our 2014 paper. That's where the data ended. So this was all new data to check it out on. So that's why we chose those periods.
Okay, thank you.
David, thanks very much for this great talk. Didn't Phillips, in the original paper, didn't he include import prices or raw material prices or something? There was something else that he had in his model, isn't that right?
Not in the basic model.
Okay.
The first model he did, he had lots of other things because he knew they all mattered. But the original model was simply delta W and UR. That's the one that he did in the complicated way that Meghna Desai discussed.
Yeah. You kind of hinted at my point, my second point, which is that if one thinks about power, the power relationship between employers and workers suggests that in periods where the employers have the upper hand, the prices that matter are the prices that the employers are able to get for their output. Whereas in periods where workers have the upper hand, it's the cost of living that the workers face that's more important. So there ought to be a kind of switch in the prices that are relevant in the long run relationship. I'm wondering whether the data actually would allow one to test that. And related to this question of power, it isn't only unemployment matters, but also unionization. So, when unionization collapses, there's a big shift in that power relationship, and you would have thought that would affect the dynamics of wage setting.
Yes, well, in the original paper, we looked at trade union membership as a measure of trade union power and couldn't find anything affecting our model in it. So logically, yes, the period up to of the First World War has got very low trade unionization, then higher on trade unionization, but it doesn't do the workers any good. there's huge increase in trade unionization of the industrial and mining sectors during the war. But again, it got high wages, but then they made the mistake of indexation, and that led to the general strike. And the general strike tells you workers had no power, right? They were desperate to get their real wages back and couldn't because of this huge fall. It's not compensated until we get to the Keynesian increase here. And so whatever the trade union power was, it was totally futile. 1926 ended in defeat for unionizing everybody, calling everybody who's unionized to strike, and it didn't work. So I'm not absolutely sure that the unionization variable has got much to do with the long run, whether it comes out in unemployment or in nominal wages, real wages. And we certainly couldn't find it in our earlier study. We tried a number of variables like unemployment benefits, was that doing anything, and so on. We couldn't, none of them seemed to matter in this general model.
Right. But you hadn't checked for this switch in the price indicator combined with union density.
No.
Yeah. So is the combination of high unemployment and union power that effectively governs the power relationship, isn't it? I mean, high unemployment will dominate, as you were suggesting. When there's very high unemployment, union power doesn't matter so much. It's only when there's low unemployment that union power really matters. Yes,
and of course this is the I'm all right, Jack period, as it's known. But in fact, wage inflation isn't particularly significant over this. It's higher than it was, but productivity growth is much higher than it was. And so this period here, although it's called the I'm all right, Jack period, it really is showing you can run an economy at very low levels of unemployment and not have much wage inflation as a result, over and above the growth that was due to changes in productivity.
Thank you very much.
Lucas.
Thank you very much for the fascinating presentation, including the biography of Phillips, which I really enjoyed. Despite having worked on the Phillips curve myself, I hadn't known anything about this fascinating biography. Now, what I was wondering was whether you had any sense of whether the structure of the labor market over the long run affected the Phillips curve and perhaps would lead to some problems that you could not pick up in your measures. On the one hand, in the measure for unemployment, and who is counted as part of the active labor force and who is counted as not part of the labor force, and how that may have changed over time by measurement, but also by social conventions of people. And second, everything around hidden slack. So thinking of involuntary part-time employed, involuntary temporary, and marginally attached workers, and whether that you would think would make any difference to your estimations.
Yeah, all of these things potentially matter, and the step shifts that we picked up are fundamental. Until we found the step shift between before 1945 and after 1945, we could not find a sensible real wage equation. It was just impossible. Everything just had the wrong sign, the wrong magnitudes. It didn't fit very well. And then when we invented step indicator saturation, it was one of the triumphs that it suddenly showed, if you look at the data on wage inflation, it's very hard to see this huge, what is a huge shift in living standards at 0.7% per annum up to 1945 and 1.7% after. And yet when you look at the changes in real wages, you don't see that. But when you draw it in, you see it immediately. Now, of course, by using a step indicator, it means ignorance. We don't know why it shifted. We conjecture it's the upscaling of workers during the war and learning about radar and radio and trucks and all aircraft, etc., etc. So a huge upskilling in the war labor force and in the non-war labor force. The women in the labor force, the older people in the labor force, they ran the country, right? They kept producing the aircraft, the guns, the bombs, etc. So these are very hard things to get measures of skills. And so I think that step shift is picking up a great deal of that kind of change. And part-time working, well, there's a lot of part-time working during the war, but it's it's unclear. They don't count as 0.1 unemployed or whatever. And of course, now we've got 0 hours contracts. That's why I say it's astonishing that this kind of aggregate equation is constant over a huge period of massive change, social change, institutional change, real living standards changes. People forget that up until 1914, poverty was rife. I mean, any photograph of children running in the streets up to 1914, children have bare feet. Their parents cannot afford shoes for them. After 1945, you almost see no children with bare feet, right? There are still some at the early period, but as the time goes on, they're all wearing shoes. Living standards are rising rapidly. That's why you get Macmillan's "You've Never Had It So Good," because they'd never had it so good. I mean, okay, it wasn't great, but it was a darn sight better than it had ever been. So yes, there's huge, huge changes that are going on. And the only way and notice we have all the productivity variables in the equation. So whatever these shifts are, they're over and above the impact of output per person per year on real wages. So there's something else going on. Of course, this one, that has to be an indicator. I mean, Keynes just said, you want people to get into the labor force, right, increase wages dramatically. And so 14%. And if you go back to the archives, which I did with the National Institute about 20 years ago, because they didn't believe it had happened. It's there in the data. GNP leaps with this, because of course GNP is measured from the earnings side as well as the others, and it just jumps. And then you can find it in the records that it was a Keynesian innovation. So that, I mean, just all these things are going on, and it always struck me that we're kind of scrabbling at the surface, but this equation, it even stays constant over this crazy period of Brexit and the pandemic and the furlough scheme. I mean, so many things, and yet its forecasts are from here out are perfectly respectable. And this equation predates all of those, right? It was 1912, 1911 that we stopped. So yes, I think many things, as John mentions, that probably matter, but they must be reflected in part in the variables that are in the model, or matter at the margin rather than as massive effects over the whole 150 years of data. Because even the huge change in the measures of unemployment that Tim Hatton and his co-authors got by going back to the archives, they hardly change the relationship between nominal wages and unemployment. Our equation is very similar to Bill Phillips and a completely different measure of unemployment.
Thank you very much, David. Anyone else, any more questions? We're just coming up to 3 o'clock, but there's still a little bit more time. No, it sounds like you've covered everything, David. So I'll say thank you very much, everyone. Thank you, David. Thank you, Jenny. And we'll see you all at the forthcoming events.
Thanks for all the questions. Bye.
Bye, everyone.